Okay, so we're going to continue talking about our three conversion factors. At the end of the last video, I was in the middle of a problem, and so we'll repeat that problem and get an answer before we move on. So right now we're featuring Avogadro's number and the molar mass, and we're seeing how we can use these two conversion factors together to actually get answers to problems. So let's go ahead, and the last one that we did in the last video was that we're asking for the mass in grams of one copper atom. So it asks for it in grams. So let's pull the information out of the problem. What we want is the grams of a copper atom. And we've got one copper atom as what we started with. So we went through the logic and we said we can go from atoms to moles with Avogadro's number. We can go from moles to grams with our molar mass. Alright? So we're going to use those two conversion factors to get all the way from atoms to grams. And then here's our logic. Now let's go ahead and do that problem. We've got one copper atom on top. Number of copper atoms is on the top, so copper atoms have to be on the bottom. And Avogadro's number gives us how many atoms that is. 6.02 times 10 to the 23rd copper atoms in 1 mole of copper. Okay, this basically comes straight from Avogadro's number. Now we need the molar mass of copper in order to convert it all the way to grams. So the molar mass we can get directly from our periodic table. I see copper, and copper's number is 63.55, and the units on molar mass are grams per mole. And that's of copper. Okay. So we're going to use that number with our conversion factor here, as our conversion factor. So we've got moles of copper in the top. So moles of copper have to be in the bottom to cancel out. So we've got mole of copper. The thing on the other side of the line has to be on the other side of the line. So we've got 63.55 grams of copper. Those will cancel out. Those will cancel out. And the only units we didn't cancel out is grams of copper. That's exactly what we were looking for. So I believe this is where the video cut out last time. So let's go ahead and do that calculation. We've got 63.55 grams, and we're going to divide it by 6.02 EE to the 23rd, and we get a number of 1.0556 times 10 to the negative 22nd. That's what's directly off the calculator. Now we do want to consider significant figures. We've got an exact number. We've got 3 significant figures here. We've got 4 significant figures here, exact number. So the lowest is 3 significant figures. So we're going to express this in 3 significant figures. Here's 1, here's 2, here's 3. We go next door to see if we can round up or down. That is 5, so we're going to round up. So that 5 becomes 6 at the end there. Don't forget your exponential term. And here is our final answer. Let's go ahead and do another one. In this one, we say that we've got a tablet of aspirin, and we are given the formula for aspirin, C9H8O4. And that tablet has 0.34 grams of aspirin in it. And we're asked for how many molecules of aspirin are present. So again, the first thing we're going to do is pull that information out of that problem. Okay? So we're told that one tablet has 0.360 grams of aspirin. And it asks us for how many molecules of aspirin are present. Okay. So we're going to start off with the grams of aspirin that we're given. We've got 0.360 grams of aspirin, and we need to figure out how many molecules that is in that aspirin. So let's think through our logic. we're starting off with grams. Can't do anything with grams, right? So probably we're going to need to convert that to moles. So moles here, how do we do that? Which conversion factor converts grams to moles? Well, it's our molar mass, right? Then once we have moles, the only conversion factor which has molecules or atoms or different items is Avogadro's number. So then we're going to need Avogadro's number to convert moles to molecules. Okay? Let's go ahead and do that. We did say that we're going to need the molar mass. So let's do a little side equation here. Let me adjust the screen so you can focus on this problem. And we need the molar mass of aspirin. So we're going to do a little side problem here. We have 9 of the carbons, which are 12.01 each. We're going to add 8 of the hydrogens, which are 1.01 each. And we've got 4 of the oxygens, which are 16.00 each. And we're going to add those guys all up. And you can do it just like I'm doing it. So I'm doing the calculations here with you. And we will get an answer of 180.17. And this is the molar mass. So the units of molar mass are what? Grams per mole. Grams per mole. It's always 1 mole. That's the aspirin we're talking about. I'm just abbreviating it so it takes a little less time. So we've got grams of aspirin up here. Where do they have to be to cancel out? Well, they have to be on the bottom. So we're going to put grams of aspirin here. We're going to look at our conversion factor, and that number goes along with the grams. So we're going to put 180.17 down there. What's on the other side of the line, the conversion factor has to go on the other side of the line here. 1 mole of aspirin. So that cancels out that. We stop now, we would have a mole of aspirin, or how many moles of aspirin are in a tablet. That's not what it asks for. It asks us for the number of molecules. So we're going to keep going. Let me erase this molar mass, because hopefully by now we're all getting the hang of doing molar masses. And that way we can focus on the problem a little more. We've got moles right now. We said we're going to use Avogadro's number to get to molecules. We have moles in the numerator, so where does that have to go to cancel out? Has to go in the denominator. So moles of aspirin, we've got 1 mole in 6.02 times 10 to the 23rd molecules of our aspirin. Moles cancel out with moles. The only thing we didn't cancel out yet are molecules of aspirin. Before we pick up the calculator, let's double check to make sure that's what we want. Moles of aspirin, or molecules of aspirin, molecules of aspirin. That's exactly what we want. So now we can go through and do the calculation. So we've got 0.360 times 1 times 6.02 EE to the 23rd. Then we're going to divide it by the 180.17 and divide it by 1. We end up with 1.20286 times 10 to the 21st. That's what's on the calculator. What do we have to do before moving on to the next problem? Significant figures. Exactly. So we've got 3 significant figures here. Exact number, that's 5, which is more than 3. We've got 3 significant figures here, and that's the exact number. So we need 3 significant figures in our answer. So let's count them off. 1, 2, 3. The guy next to it is a 2. So we're going to round down. So it's 1.20 times 10 to the 21st molecules of aspirin. So there is our final answer. So we can see that we've covered these first 2 conversion factors with a number of different problems. We've shown how they can do them individually, and we've shown how we can actually do them together in different problems to get our final answer. So we're going to continue on and start talking about molar ratios in our slides, and then we'll have another video to do some calculations there.